In this video, we're going to look at solving rational equations. You've actually done this before. There's a very basic way to solve basic rational equations that we're going to review. I'm going to call that the old way. And then we're going to look at a new way. And the new way is helpful when you get to the more complicated rational equations. So remember, a rational expression is basically a fraction. So if we have a rational equation, we have a fraction equals a fraction. Well, the old way of solving a problem like that is to basically set up a proportion, which it'll already be set up as a proportion. All right, so set up a proportion, and that just means have a fraction equal to a fraction. It does have to be a single fraction equal to a single fraction. So set up a proportion and then cross multiply. All right, so that will look familiar to you when we do that in just a minute. And then of course, once you cross multiply, you no longer have a fraction equals a fraction. And so you need to just solve the remaining equation. Okay, well, I'm also going to show you an alternative way. Okay, I'm going to call it the new way. And I'm going to show you that if you understand the idea of a common denominator, it actually gets you, for most of the time, gets you to either an easier equation to solve or it gets you to the equation to solve quicker. All right, and so the first step in the new way is to get a common denominator, all right, in all fractions. All right, and that because you may end up having more than one on each side. So that's why I'm saying the new way is going to be easier when you get to the more complicated ones. So get a common denominator in all the fractions. And then once all the denominators are the same, all you have to do is set the numerators equal to each other. And then I'm going to leave a blank there, and then you would solve. Okay, and the reason that once you get the common denominators and all you have to do is set the numerators equal to each other, the reason you can do that is because there's a property that says if, let's say, A divided by C equals B divided by C, all right? So if we have two fractions that are equal, that we're saying that they're equal, and we know that the bottoms are the same, then the tops must be equal. Okay, and so that's exactly what we're going to do. We're going to make it so that the bottom of our fractions are all the same, and so that all we really have to do is set the numerators equal to each other and solve. Okay, and then last but not least, before we actually get into some examples, you need to always, always check your solutions to make sure they don't make the denominator equal 0. And I'll talk more about that as we go through here. Okay, all right, so let's just get into some examples. And I'm going to start off with some basic examples, and I'm going to show you, I'm going to solve them both ways. Okay, all right, so for example, for our first example, I'm just going to take a simple rational equation. Okay, I'm going to write it twice because we're going to solve it twice. And after I do it both ways a couple times, I'm going to stop and only do the new way. I just want to show you how they compare. All right, so with our old way, all right, we would, since we have a single fraction equals a single fraction, we would cross multiply. All right, so we would do 7 times x, and then we would do 4 times x minus 6, and of course we would have to distribute to 4, and then we would combine like terms on the same side. So let's see, we would move this, we would subtract this 4x over here, 7x minus 4x is 3x, and then we would divide by 3. Okay, and then you do need to check to make sure that when you plug this number back in for x, when I plug it back in for x in the original, I do not get 0 in the denominator on any fraction whatsoever. So negative 8 minus 6 is not 0, negative 8 by itself is not 0, and so then I get to keep this answer. Okay, now the new way, right? The new way, it seems a little more complicated at first, but all you're doing is deciding you're getting a common denominator, okay? Well, if they don't match, remember the easiest way to get a common denominator is to multiply by each other. So if I multiply the bottom of this one by x, I would have to multiply the top of this one by x. If I multiply the bottom of this one by x minus 6, I'd have to multiply the top of this one by x minus 6. But once we do that, they now have a common denominator, and as long as the bottoms are equal, then the tops are automatically equal. And I can simplify the tops as I write it down. So x times 7, and then I'm going to distribute the 4x. And you will notice that you get exactly, you get to this step, all right? You get the exact same equation. You just decide at this point which one is easier for you. And then, of course, you would continue to solve it. And so the answer would still be x equals negative 8, right? Because you would still subtract 4x from both sides and divide both sides by 3. All right, so in that one, it doesn't seem, you know, ideal to use the new way versus the old way, but later I can tell you that it will, okay? All right, so let's do another example, both ways. All right, so number 2. All right, again, I'm going to write the equation down twice because we're going to do it the old way and the new way. All right, so the old way says let's cross multiply. All right, so this one would give us r times r. And then, of course, 4 times r minus 1. If you're comfortable distributing before you write that down, feel free. All right. Now, keep in mind that if you have a variable squared in your problem, right, and another variable not squared in your problem, to solve it, you are going to have to make it equal 0 and factor. Okay, you are going to have to make it equal to 0 and factor. All right, so real quick refresher on factoring. Let's see, we do an r and an r. We need two numbers that multiply to be positive 4, but add up to be negative 4. So that's going to be negative 2 and negative 2. If they are the same, remember you only have to actually solve it once. Let me get some more room here. All right, and so r equals 2. And again, just make sure that if you put 2 on the bottom for r, on either bottom, you don't get 0. If you do get 0, you're going to have to cross that answer. Okay, now the new way says let's just get a common denominator. Well, again, the common denominator here is just going to come from multiplying the denominators by each other. So the first one needs to be multiplied by r, top and bottom. And the second one needs to be multiplied by r minus 1, top and bottom. But again, once you do that, once you make the denominators the same, you don't need them anymore. Okay, your very next step is just the numerator equals the numerator. Again, that got us to the same equation in the same amount of steps, okay? And so just like we did earlier, you would have to make this equal to 0 and factor in order to solve. All right, factors exactly the same way. And so you get exactly the same solution. So again, not a big difference. All right, let's move on to my third example where you're going to see a little bit of a difference. Okay, all right. So again, I'm going to write this down twice. Okay. And we're going to solve it two different ways. All right, so the first way, we're going to go straight into cross multiplication. Now be careful when you cross multiply, all right? It might be helpful to actually write down what you're multiplying by each other before you actually go and do it so that you don't miss anything, because you do have to distribute. All right, and because we have x squares and x's, remember that we have to make it equal to 0 before we factor. Well, I want my x squared to I want to make sure that it ends up positive. So I am going to move everything to the right. All right, just showing you what I'm doing here real quick. All right, and so then all of these cancel out, and I get 4x squared plus 8x. All right, and then it really doesn't matter which side the equal 0 is on. So if I feel like moving it over here, I can. And then I'm going to factor. This has a GCF, which makes it a lot easier to factor than trying to unfoil something. And then I'm going to set each factor equal to 0 and solve. Divide by 4, minus 2, and we get 2 solutions. But remember, you have to check your solutions, meaning you need to plug 0 in place of x on the bottom of each fraction and make sure that you do not get 0 when you work it out. All right, well, 0 gives me 0 plus 4 is 4, 0 plus 2 is 2, so both of those are okay. I can keep this one. But when I plug in negative 2 right here, 2 times negative 2 is negative 4, and negative 4 plus 4 is 0, and I cannot have 0 on the bottom, so I have to cross that one out. Okay, so we did get a solution. We got 2 solutions at first, but one of them doesn't work. All right, now, I mean, that wasn't too bad, all right, but let's look at it by doing the new way, okay, where we would get a common denominator. All right, well, remember, getting a common denominator doesn't always mean multiplying by each other. That is one way to do it, but if one of the denominators can factor, all right, they might already have something in common. And so if I factor this first denominator, I see that I actually already have an x plus 2 in common. And so to make a common denominator, all I really need to do is multiply the second one by 2. Okay? And once I do that, I no longer need the denominator. All I have to do is set the numerators equal to each other. Make sure you do multiply this one by 2. Okay, well, that's a lot more simplified equation to deal with, right? We just have to get our x's together. So I'm going to subtract 2x from the left to the right. And that's going to give me 0 equals 4x. And then I divide by 4, and x equals 0, which we know works because we checked it earlier. And it doesn't give us the answer that doesn't work, okay? So it gives us the same answer that does work, and it doesn't even, we don't have to factor, we don't have to do anything. So that's personally why I think the new way is a little bit easier. But you will also see that it comes in handy when the equations get a little more complicated. So I'm going to stop the video here, and then I'm going to do 5 more examples in a second video. They're a little bit more complicated, and I'm only going to use the new process. All right, so I'll see you back in a few minutes.